So we're going to talk about branches, and I'm not going to talk too much about the reason that we do these things. I'm going to give you some examples, but I'm not going to go. Let me share screen. I'm not going into a lot of detail because actually there are many and varied uses, and people use these things quite differently in different places. So I'm going to point out sort of the common uses, but it's not an exhaustive list. It's not how to do everything in Git type of session, but we are going to make use of branches, and I expect you to be using them in the project next week. So it's more of sort of practical. Look, these are the commands you have. This is what it does. In terms of workflow, that's a lot more dependent on what you're doing, why you're doing it, the size of your team, and actually if you're out in industry, possibly a lot more to do with what the standard is there in that particular organization than anything else. So, for example, if you're working with other people, it might be that the expectation is that you have one master repository and everyone forks that, works on it and submits pull requests, or it might be that people work on individual branches and submit merge requests for that, or it might be that people even work in teams on an individual branch and they use pair programming and they work on it together, and it's more interaction between programmers. None of those are right or wrong. So that's just putting that out there, that I'm not advocating a particular thing, mostly because people get quite het up about it, and I'm not particularly precious about it. I think there's lots and lots of uses for things, and do whatever you need to do. So the lookup for this, so if you go to the version control bit on the quick start, there is a bunch of stuff on branches which takes you through all the stuff that you need for now, and also a link to something that I actually quite liked as a resource, which talks about how to go through the branches, because it's a nice quick sort of list. Okay, so as a reference, it's there. If you're not sure what half this means, or you want more stuff, there is tons and tons of things about Git out there. Okay, so go and have a look. There is just endless amounts of information, and most of it quite good. So you can get into it more if you want to. What we need to do, though, is to think about what exactly a branch is and what we're going to do with it and how we actually operate on them. So far, we've talked about a Git repository as being a collection of code and the changes that have happened to that code to get to a particular point. Okay, so all of those changes have a commit with them, so it'll say, right, this was what the person that submitted this group of changes meant, or what they wanted to record with this. We know who did it, we know when it happened, and we've got the incremental changes. And what that means we can do is we can go back, we can change things, we can see where things happened. So we know, if something doesn't work now, it might not be something that just changed. It might actually be something related to something that happened previously. And we can look at when that happened and then roll forward to see if we undo that change, would it have any further impact? So it gives us lots of really fine-grained control over things. We can also tag certain points. Okay, so one of the things that's useful and has been around in most version control since the early days of what was it, SVN, you can tag a particular version and say, right, that's a particular release, or that was complete for this set of features, or whatever. So that's kind of where we've got to. But when we work on things collaboratively, or we're working on things that are complex enough to have multiple sets of features, we might want to say, well, this bit I want to keep as is, and I want to be able to carry on working on that, or keep that as a current stable version. But I also want to say, well, I need to make a second clone of this almost, so that I can work on something separate. Now, what you could do is fork the repository and keep the two things separate. Sometimes that's appropriate. If this is a proper fork of a project, then by all means go and fork the project. If they're not really going to need to be realigned later, then it's a simple thing. Even if they are, you can still make merge requests. But generally, if you see someone else's code and you want to work on it yourself, and you're not really interested in working with that person, but you want to take it in a new direction, fork would work. If, on the other hand, you want to do something that's a little bit closer to the main, and maybe you're thinking, I want to work on this for now, but I want to maybe at some point later put all this back into that main track of changes, that's the kind of place where we'd use a branch. All right, so my preference for branches is to use them for features. So you can actually say, well, this is the main bit. I can go and work on this branch and leave that bit alone so people can carry on improving, bug fixing, and all that kind of stuff for the main set of features. But at the same time, I can work on this bit separately. And I can even, like, if I realize people have fixed some bugs that, you know, I want in my branch, I can merge that into my branch and continue without affecting them. And when I'm ready, I can say, right, this is done. Now let me merge that back into the main branch. Okay, so if you look at that diagram in that link, it's quite a nice little example of how this works. Now here they've said your work and someone else's work. For me, this could just as easily be your work in the middle on master, your work on a particular thing in blue, and your work in orange, but for different purposes. Okay, one of them might work on the back end of a system, one might work on the front end, or one might be, you know, switching to a different set of libraries or refactoring something, you know, whatever you need to do. And then once you've got that done, you then merge it back in. So it's almost like having a tentative separate development. So you can go, oh, do you know what? Maybe this won't work out and I'll just ditch it. And it doesn't even affect the main branch. But if it does work, I can merge it back in. Okay, so how do we actually do these things? Well, the first thing is that we want to be able to see what kind of branches are there and work with them. So I'm going to show you this in terms of the exfiltrator. There is an exercise for you to do in a bit, which is on a completely separate repository, so you can do it without causing yourself any mischief on the current project. But I'm going to do it with exfiltrator first. So let me just pop over here. Okay. So let's do it in this one. Okay, so here's my terminal, and I'm going to do the screen key. Okay, so you can see what I've got and what's going to be what keys I press. Okay, so I've got in checkouts, I have exfiltrator, and you can see, remember we always have this master thing that pops up on the end of our prompt. So I said one of the reasons I use Z Shell for this is because it gives you lots of visual feedback about the virtual environment, but also about the state of your Git repositories. And I quite like that. And I thought it was useful to set that as the default for the VM that you guys use, because actually, you know, it's kind of useful for you to start sort of seeing that information visually there. Well, I said we didn't really need to know at the time what master meant, just that that's what we're working on. But actually, master is our main branch. That's what we've been working on all the time. And that little symbol in this particular shell is just showing us that this is the branch that we're on. Okay. So if we wanted to see what branches are available, we could just type git branch, and you can see here that it's got master. And if you did this on yours, you'd probably find it wouldn't have this line objectified. Okay. What you would find instead is that that's a remote branch. Okay, so now I'm going to do git branch -r, and you can see a different list. Okay, so what do I mean by remote branch? Remember that when we clone a repository to our local machine, what we're doing is we're making a copy of that repository. Well, actually, we're making a copy of the current version of that on origin head, which is like a pointer to the current main branch, okay, which is usually called master. And this is why these are prefixed with origin head, origin master, origin objectified, blah blah blah. The reason they all have origin on is because it's saying that's coming from the remote original repository, yeah, to where this came from. So when we look at git branch -r, what we're seeing are the branches that are on that original repository, the origin. This is just telling us that the main repository is origin master, the main sort of branch is origin master, sorry. And you can see that we have two versions of this, origin master and origin objectified. Okay, so if we're going to switch to those branches, the first thing we do is do a git pull just to make sure that we're the most up to date, and in this case we are. And then we're going to use let's get the thing up, because I'll make sure I do it. There's actually multiple ways to do these things, which makes things sometimes a little bit confusing. And if you've used Git before and you see me doing things in a different way, the reason I'm doing it one way and not the other is I'm trying to do it in the way that is clearest rather than the way that is always the slickest. Okay, so there are other ways to do many of these things. So we can do a lot of this with the branch command instead of using what we can do here, which is checkout. But I'm going to show you with checkout and stick to that. So just bear with me, and if you feel like you know a better way, you might well do, but it's not necessarily the clearest way. Okay, so branches, we've done listing branches. Now we're going to switch branches. Okay, so for a local repository, we can just do it like this with Git checkout. Okay, so we can pick this. But if it's a remote repository, then what we need to do is this instead. Okay, so let me do that in a fresh copy of this so you can see what it would look like. So I'm just making a clean directory, so there's definitely no danger of us overwriting something that we've already done or getting confused with something that's already there. And I'm going to go to the repository for Exfiltrator. Oh, didn't realize I haven't made that clickable link, but anyway. So there it is. I'm going to clone this just as is, so you can see on here as well this little branch symbol and then master. So git clone and let's just copy some. Okay, so go into Exfiltrator, and you can see we're on branch master, and there it is. And if we do git branch, you can see we only have one local branch. Git branch -r for remote. Git branch, sorry, let me spell better. And then you can see there are others. So what I'm going to do is I'm going to do git checkout track origin objectified. Okay. The nice thing about Z-Shell in this case is it will also do tab completion on these things. So pressing tab will actually look and see what branches there are at this point and complete it for you if you can spot one. So I'm going to do this. Now, the reason we put this -- track in is because we want it to be recorded that this is the equivalent, the local equivalent of a remote branch. So when we push things back, we're not going to be trying to push a different branch with the same name. We're actually pushing a new version of that branch. Okay. So obviously I'm doing it on my version of the repository. If you fork the repository, you'd be able to push back to yours. You won't be allowed to push back to mine. So I suggest you fork before you do this. Okay. So what has actually happened? Well, it looks very similar, except you'll now notice that it is telling us that we're in a different branch. Okay, so you can see that we're here. Now that I've done this once and I've got that version, if I do git branch, I seem to be able to spell, you can see now that I've got master and objectified locally. I didn't use the -r switch, so that means that these are both local. And also you can see there's a star next to the one I'm currently using. So before that star was on master, and that might have been the only thing that was there, so you just see star master. Now you can see that star is actually highlighting which branch we're currently on. And if I want to switch, so I can switch to master, and you can see it has changed in the prompt, which is helpful. If you're not using Z-Shell and using Bash and things like that, you might not get any indication, but you can always check with git branch, and it will tell you. Look, you can see that we're now in master. So we can switch between these two things. What does it actually mean? Well, what it means is we have different versions of the code in each one. So let's just prove that for a second. Look inside source. You can see we have xalice, xbob, and xf, the set of library things that you might want to use. In fact, let's do ls-l source, and we can look at the size of them. Git checkout, and I'm going to switch now to objectified. Because I've already got it locally, I've already done the checkout with the track and given it the origin objectified. I now have a local copy. I can just switch to it with git checkout objectified. I switch to that, do ls-l source, and look at this. Xalice is still there, but he's a different size, has different content. Xbob is still there, but he's a different size because it's got different content. exf.py, same size, still there, but we also have demo.py, catcher.py, and collector.py. So we actually have a bunch of new things. What we can do is we can work on these things in here, and then we can merge those into the main branch. Okay, so let's have a look at how we would do those things. Again, go back to the guide. So switching between branches, merging branches. First of all, we go to the branch that we want to merge into. Okay, so if we want to merge these into the main branch, we get check out into master. Let's do that. Okay, so now we're back in master, and next thing I want to do is to merge the stuff that's in the new branch. So all through here, I've used blah to be the other branch. In this case, it's Objectified that we want to work on. So git merge. And then I'm going to use tab because you can actually see where these things are. And just to show you, there are lots of things that you can do. You can actually go to master, Objectified. You can even go for origin master if you've got things on the origin that aren't locally. Okay, or you can go for individual commits with these things down the left hand side. So these are actually things that have happened over the past few days and hours. Okay,
James,
so yeah.
What is origin? As in,
origin is the place that this came from. So origin in this case is the github.coventry.ac.uk repo. So it's just saying this stuff comes from over there. And that's why when I did the checkout with the track, I was telling it to get it from the remote repository. So origin/Objectified, and track meant it's always going to remember that that's where it comes from. So it knows that if I want to pull a new version, these things overwrite each other or merge with each other. Okay.
okay, fine.
So I'm going to git merge Objectified, and you'll see a bunch of things happening. So what happens is it runs through the changes that have happened and aligns the two things. Now at the moment, what it means is that now in master, if I look inside source, I have all of the stuff that was in Objectified. Effectively, they're now the same thing because there were no changes that were in one and not in the other. So that's where we are. If it was something more complex and there'd been some larger scale changes, then this would be different. So I'm going to try and force that to happen now to show you. So one thing we have to do is we have to create a branch, and actually it's quite an easy thing. We can just use checkout with a -b switch to create one. So I'm going to do, in fact, let's do git status just so you can see where things are. You can see there's nothing done, but we are ahead of master by 5 commits. What that means is that even though this was a fresh checkout, because I've actually now merged all of the things that happened in Objectified, he's now ahead of what was on there. Okay, so that's where we are. If I want to undo this merge, I can always revert back to what the origin master is. Okay, so let's see what the easiest way to do that is. I always still look up git commands, so don't feel like you have to remember all of these. It does too many things for you to remember everything. Git merge. No, it's not already pushed. Roll back git merge. Here we go. There we go. So we can just use reset hard and then the thing that we want to get to. So let's do that just for making it easy. Git. So I've already forgotten reset. Hard means just do it. Overwrite stuff. Yeah, just go for it. And I'm going to go for origin. Git status. Up to date with origin master, nothing to commit, working tree clean. So we're back to having everything the way it was. Okay, so we've basically just gone, Joe, everything I've got here, forget that, go back to what was on the origin at master and put that as here master. So we're back to having those 2 branches. Everything is back to normal. Okay, so what I'm going to do is I'm going to make some changes that cause Git to be unable to automatically merge things, right? Just to demonstrate what happens when you're in that situation. So go to Emacs and just need to move that along. see what I'm doing. TMP. Okay, so in here we had some changes in Xbob. Okay, so what I'm going to do is ignore the fact that I'm changing this in Emacs for a second, because that's how I normally work. You can see there are a bunch of things that change down here. So what I'm going to do is I'm going to take some of those changes, okay, and I'm going to then go back to the main branch. There we go. And I'm going to put in something that is incompatible, right? So I'm going to say that -W now is a different switch. And it does a bunch of random stuff. We don't need the next bit. So what I've done is I've got one line which should be quite difficult for Git to be able to merge. Okay, so we have these two things. So what I'm going to do is I'm going to go back to the thing here. Git status should show us that we have this modified. Okay, so git commit source xbob. Okay. Oh, I didn't put the -m for the message, so it's automatically fired up an editor for me to do it. I don't know if I've actually shown you that before, because I almost always do it from the command line with the -m, but anyway. And it's not a very good commit message, but I'm going to revert this later anyway. Write and quit. Status, yep, so there we are, we've got a local version. And now I'm going to try and merge Objectify. Okay. And it says there are merge conflicts, okay, and it tells me where they are. It says automatic merge failed, fix the conflicts, and then commit the results. And if you look here, you can see now we've got this extra symbol, which tells us there was a conflict. And if I go over to my editor, you can see how it shows us what's going on. So this is where we were, and this is what we tried to merge. Everything else it could merge, but these two bits, it got really confused about. Okay, so what we need to do is we need to fix the code between here and here ourselves. And Emacs is highlighting the colors for me and stuff, but if it's not highlighting the stuff, it's just text. These are just bits of text. And actually, what I want to do is I go, actually, you know what? That bit's no longer needed because it's now implemented by this. And so that's what I want it to look like. Go back over here, git status, and you can see I've now got all of the stuff that's been changed. They're already ready to be committed. So it knows that, yeah, that's all fixed. It's, you know, we've done all the stuff, and I can now just do git commit -m merged Objectify. There we go. So it gets to the same point of having those two things merged, but we've solved that problem. You're probably not going to come across that unless you're actually doing quite extensive changes. If you think about why you're branching, you know, you tend to have, you know, reasons for doing things a certain way. So you're only getting small parts. If you find that you're trying to merge things and you get absolutely loads of those, then you've probably diverged so far that, you know, you actually do need to forget that Git can merge them for you, and maybe even just merge the stuff by hand. You know, just let it show you all the places and go through and do it. But hopefully not. Okay, now I'm just going to undo that again with reset, and there we go. So we've got all the stuff there. If we want to make a branch, you know, I've shown you this. I'll just do it on here just to show you. So git status, git branch. So we only have these two local branches. Git checkout -b to make a branch, and I'll make one called random stuff, and now I have a branch called random stuff. Okay, all done. All right. Okay. So that's the quick introduction to branching and merging. It seems like a fairly straightforward thing. In practice, can quite often cause you a bit of a headache the first few times you try it. The only way to really get through that is to you know to do it, you know, make the mistakes and move on. Dan, are you waving at me to?
I am waving at you. So I've found it again. I've just dropped it into the chat. I've also dropped it onto Moodle. I've gone back a year in time.
Oh,
Yeah, that's it. That's the thing. The thing. I put it on the thing, right? And there's a nice, I'll drop it in here again. There's a really nice demo, interactive demo of using Git, and you can run the commands in it. No, that's answering a different question. The one that I've just put underneath, learn branching,
Okay.
js.org. Right.
Ooh.
I remember finding this a few years ago and playing with it and being really impressed with learning. So you can do your commits. It will talk through the heads, what the head means, and you can visualize it as you're typing your commands. So what I would do is run through this. Some of it is really basic, but now they're explaining what's going on. So you see. But if you're unfamiliar with Git concepts, it's really, really nice. Some of the questions that have been asked, like Mahin and Mattia, so merging specific files from is a corner case. Like Git's not expecting you to do that, and it turns out to be harder than you were expecting. And explaining what the head of the branch is, again, it's the top of the branch, right? So most recent version that's been checked in, but with branching, it may not be the most recent version of the code.
Yeah.
Because things get complex. This little visualization will help you see what's going on with that. So if you play with this, oh yeah, and here's the other one. Here's GitHub's official one, which is not quite so nice to use, but it helps again visualize what's happening. So,
That's
but
really
this
cool.
is really that I found this a couple of years ago, and they've made it look even more flashy. But it's really, really nice. So, and I've been looking for it for ages, and then I found it again. So there we go.
That's really awesome.
Learn Git. I would play with this, folks, and see what's happening. But
that is really nice.
Yeah, if you view the other ones, so the Git School link that I've just dropped in as well. This is GitHub's official one. Just to feed you through it, if it works. Go on, Git, visualize. I did give the right link. Yeah, I did. So Git School, github.io. Weird. Doesn't like you.
No.
Oh, there it is. So here, and this just, it's only because of the head stuff. If you do a commit, yeah, so this only understands commit, branch, etc. So if you do a branch, just okay, now do another commit. Yeah, and you'll see where the head moves, and that might help explain what's going on with the heads. But
so if I then switch back to master, keep one. Sorry, I'm trying to use tab completion, and I forget I'm not actually in a shell.
So there we go. That's explain that shows you what's happening with the head here.
You can see now these two things are running parallel, so they are literally two branches. Can I merge from here?
If I remember correctly, you can. So you should.
Yeah,
it
master.
does. Yep.
Oh,
so there we go. So, but this comes out of the materials that Git has done for me as like I had to sit through the GitHub ambassador program thing. But it's nice to look at. But this kind of self-study, I suppose, the other one, the JavaScript one that I'm trying to click on, and of course it won't work because it's on your screen, has got the commands with it as well. So both between them, you can see what's happening. Yeah, that
is really cool.
So the only thing I would say with Git is like commits and merges. If you do them and it goes wrong, we can fix. You can shout for me and I'll be able to help you fix it. If you ever see a command that tells you to run something like git rebase, avoid it for the moment. If you've used Git a lot and you know what's going on with it, then that's fine. But avoid git rebase commands because they've got the possibility of actually destroying your history. And if you run it blindly, copying something off the internet, right, I might not be able to help you. Whereas
yeah, I think
anything else,
if you're in a situation where someone tells you try rebase, just stop because you probably don't need to do it. I think that's
just as a warning. But anything else, I can probably help you fix. Probably. Your mileage may vary. I've done fixed rebases before, but it's hideous. Yeah. It's hideous stuff, man.
Actually, that's a really good point. You should point out that Dan is the official Git master of at least for the academics at the university. I suppose the guy that runs the GitHub.Coventry is also an important Git person. But Dan's the what's the thing? Git.
I'm a campus ambassador. And they're still sending me the swag. So I've asked for like 1,000 students worth of GitHub swag. So
yeah, if you want Octocat stickers, be nice to Dan and demonstrate good Git skills. Yeah, there we go.
Anyhow, right, I'll jump off my Git horse.
They're really cool. So,
but that site I've been looking for learning branching. I've been looking for ages. They've changed the name of it, and I found it years ago, and I was really impressed. And then, I'd lost the magic words, and Google somebody, Navdeep or Nav or Mahin or somebody asked a question that meant I found it. So we should be thankful for this because it is really cool bit of kit. Right, I'll shut up. I'll see you in a bit.
Right. So I'm going to put that's really good. I hadn't seen either of those at all. So that kind of really helps with visualizing and stuff. So I'm going to put those things on air as well if they're not already there. So hopefully that clears things up. And I think if you are struggling to work out what the things are doing, like all these branches and things, that visualization is fantastic. And I've just gone through both of those quickly, but both of those I think look really, really nice to demonstrate. Simran, yes, the Git stuff is going to be important because one of the things for this module, one of the learning outcomes you need to show is that you can use version control. And so in the next project where you're going to be working in groups, in fact, we'll get onto that now before I send you off on the other thing, is that you're going to be working with other people, okay? Which means you're going to want to be thinking, well, how do I work in such a way that doesn't trample on what other people are doing, right? So you don't want to be, constantly doing a Git pull and realizing that someone's changed stuff that you relied on. What you want to do is you want to go, right, I'm working on these bits, so I'm going to make a branch on a group repository, and I'm going to pull that, and I'm going to work on it here. Yeah, this is how I'm going to do it. Or you could do it with a fork, and you can do pull requests if you know what you're doing. But I'm going to suggest branching for now, because you're only going to be working in groups of 4, and there should be fairly distinct things that come from a main repository. Okay, and okay, so I think that answers all the questions that were there. Adam, have I missed anything?
Nope, you're fine. You've managed to get everything.
Awesome. Okay. No one seems to be screaming, so that's good. I'll take that to mean that everyone's extremely happy with that idea. Good. Okay, so there's the next thing on the list is breakout and break. So let me just find where we are. Yeah, so breakout and break. The first breakout is really simple. So what I want you to do, you've got the link to this, and I'll post this link again, just for lols, because that seems to be the way it goes these days. So you're going to fork this repo, which is just called branching McBranchface, and he's just there for playing about with branching. You're going to look and see what remote branches there are. So you're going to fork it, so you have your own copy of it. You're going to then clone it, so you're going to see what the git branch -r, see what remote branches exist. There will be a remote branch. Switch to that remote branch, fix the error in the code that's there, so you make sure the code works. Once you've done that, I want you to commit the branch. Okay, so you say, right, that branch is done. I've made some changes as you would normally. Then I want you to switch back to master and merge that branch. Okay, so what you will have at the end, obviously, you can push it back to your repository to keep, but what you'll have at the end is your master branch will be the one with all of the features in it and working. Okay, at the moment, the features in the other branch are experimental. Okay, so there's a problem with them. Just to be clear, it is not going to be a difficult thing to fix. It's quite literally a single typo in a very obvious place. So you don't need to do a lot of actual programming. This is more about the repository. So go and have a look at that. You can ask questions. I think it worked okay if we just stayed in the same place. So let's all just stay in here. I think the troops idea was all right, but hasn't actually been necessary. I'll keep it in my back pocket in case it suddenly becomes necessary. Maybe in the next few weeks when there's coursework going on and people want to ask lots more questions, it might become useful, but we'll see. And the idea is that we have this stuff done. Breakout and break is like 20 minutes plus 15 minutes. So actually, I keep meaning to put actual times in here because